Okay, now we have a statement about the sum of the distances of xy from 5, 8 and from 4, 3 is 10, right? So really we've got to be a little bit careful. First of all, we want to have the distance between x, y, and 5, 8, right? It doesn't matter whether, I should have said, but distance x, y to 5, 8, but it's the same thing, because distance isn't ever negative, okay? Displacement is, sometimes, okay? Depending which order you put them. And then we have the distance from 4, 3 to xy, okay? So we have to have both of those distances. So when you read this problem, when I say the sum of the distances of xy from this and this, right? I mean the distance of xy from this and the distance of xy from this. And that's where, you know, I've got to be careful to state things fairly consistently at this point so you don't get confused about what the sentence means, because the sentence is getting a little more complicated, right? And you want to read it as carefully as you can, okay? Okay, so, well, again, we should write out the triangles and stuff, right? I mean, like you got, okay, well, I'm going to do it. You know, you got 5, 8, and xy. So you got y minus 8, and you got x minus 5. So you have the square root of x minus 5 squared plus y minus 8 squared. Right? And with practice, you should be able to write it down just that quickly. Okay? You probably shouldn't, because just like me, you might make a mistake. So you want to check yourself. Okay? And then, similarly over here, we got 4, 3, and we have xy. So we have y minus 3, x minus 4, square root of x minus 4 squared plus y minus 3 squared. Okay?
So we just add them to.
Yeah, so now we have those distances. So now we have sum of the distances, right? So that would be this. Okay? Now, if you square both sides of this, you don't get to just take the square root signs off, which most people did on their homework. Okay? But that's forgivable right now. You know, another week or two, it's not going to be so forgivable. Okay? Because, you know, algebra's not being taught very well. And almost everybody will do that. I wanted to do it, but I kind of had really good algebra courses, like the kind that were taught in the early 60s, okay? You know, remember, chiseling stuff into the stone walls took a lot of time, so we had to be careful, so we didn't have to go back and do it again, right? So you don't do that. You have to use a distributive law to square this side, and that gets a little complicated, okay? But when you do, and just a little enrichment here, it's kind of neat. Because what you get is this picture that I'll draw. You got the point 4, 3 and the point 5, 8. So let's say here's 4, 3, and here's 5, 8. Okay? Now all the points where the distance of xy from these 2 points adds up to 10, Well, yeah, what's the distance between 4, 3, and 5, 8? Well, it's going to have a 1, it's going to have a 5. It's going to be about 5.2. Okay, so this distance is about 5.2. You don't have to, you could figure that out. That'd be easy, right? Now, if I take a point down here, that looks like it's at maybe distance 8 from here and distance 2 from here. If this is about 5, then this might be about 8 and this might be about 2. Okay? Then I have another point on the other side here that would be at the same distance. Okay? Now, I could have a point out here that's at about distance 5 from this one and distance 5 from this one. Okay? And I'd have a point over here on the other side, kind of symmetric. Okay? Well, it turns out that if I do all the points, because I'll have points here and here and here and here and here and here. If I add the distance of each point from here to here to the distance from here to here, it's going to come out the same. It's going to give me an ellipse. So what we have here is the equation of the ellipse.
So the equation of the ellipse is basically the sum of two distances.
Equation of an ellipse always says the sum of your distances from this point and from this point to xy is equal to some fixed number. Okay? But there are other forms of the equation of an ellipse, and I just give this to you because ellipses are kind of neat. And if I had just a few more minutes, I'd show you how to draw one with a piece of string. Okay? Showed my grandson when he was 3. He thought it was kind of neat, but he doesn't remember how to do it. He's 48 now. No. Kids at 3 don't remember things like that. I've still got that ellipse on my floor underneath my flooring. I have to tear it up one day and look at it. Okay, well, that's totally off the subject, but, and so is this thing about the ellipse. I'm just telling you that depending on how far you pursue mathematics, you might run into that. And there are reasons why we do these things, okay? Because ellipses are a big deal. Okay, we don't want to talk any more about that, but you understand. I want you to understand why we need to be able to do the algebra of this stuff, like the algebra of squaring this, which leads to a great big simplification. Okay? So that's why we're going to be working pretty hard on getting a little better with algebra. Not everybody needs to, but most of the class, most of the whole class, not just this class. And probably more people in that class than here. People who really need it aren't here because somehow they got the prerequisites. And I'm afraid in some cases they got the prerequisites without really having them. Still trying to sort all this out. But that's why we make these videos available to everybody, right? To have the opportunity, and many of them are doing real well with it.